All right, so we're going to continue the lesson on sine and cosine. A reminder that the sine curve has this pattern. It starts at 0, it goes up to the amplitude, back down to 0, down to the negative amplitude, and then back up again. Okay, so we're on example 6. Determine the amplitude, the period, the phase shift. Obviously, this is sine, so we're going to follow that pattern, which starts at 0, goes up, okay? Our A is what? 1/2. So that is the amplitude. It would be the absolute value of it if it was negative, but it's already positive. The B is what? 2. What's in between the trig function and the x, which is 2. And then the period is 2 pi over b, so 2 pi over 2 is pi. Then we're going to take that period, we're going to multiply it times 1/4, times 1/2, and times 3/4. I get pi over 4, pi over 2, 3 pi over 4. First one would be 0, last one would be the period, which is pi. Normally I go to my graph, but because this has a phase shift, because there's something adding or subtracting from the x inside the parentheses, I know there's a phase shift here. So if 2x minus pi over 2 were to equal 0, 2x would equal pi over 2, divide both sides by 2, which is the same as multiplying by 1/2, and I get a phase shift of a positive 1/4. So to each of these points, I am going to add 1/4, or pi over 4, so no, 1/4, but pi over 4. I get a pi over 4. 2 pi over 4, which is pi over 2. This would become 2 pi over 4, 3 pi over 4. 3 pi plus pi, 4 pi over 4, which is pi. And then 4 pi over plus 4 pi over 4 plus pi over 4, which is 5 pi over 4. Now I want to graph them. They are all positive this time, and it's shifted to the right of the x-axis. Again, my amplitude is only 1/2, so I don't have to go very far. I'm going to start with pi over 4, then pi over 2, then 3 pi over 4, then pi, then 5 pi over 4. You should have 5 key points on your x-axis. If this is 1 and -1, my amplitude is halfway. And then again, we are graphing sine. We're going to eventually put cosine on these same kind of things, so it's important to remember the pattern. This one starts at 0, goes up to the amplitude, down to 0, negative amplitude, up to 0, and there's your sine curve. Because that's the first key point. Normally the first key point 0, but we shifted everything to the right, pi over 4. Questions on that one? Okay, then we talked about this briefly, but cosine, you do exactly the same steps. You're going to find the A, absolute value of A is your amplitude. The B, period, is 2 pi over B. You're going to take that period and multiply it times 4, times 1/2, 3/4. First one is 0, last one is the period. Check for a phase shift, plot your key points. The difference with cosine is what the actual curve looks like. Cosine starts at 1, goes down to 0, or starts at the amplitude really, goes down to 0, goes down to the negative amplitude, back up to 0, and stops at the amplitude. And again, this comes from the unit circle. So if I think about my unit circle, this is 1, 0, 0, 1, -1, 0, 0, -1. This was 0, pi over 2, pi, 3 pi over 2, and then all the way back around to 2 pi. Now we're plotting the cosines, which is the x. So at 0, it's the x, which is 1. At pi over 2, it's the x, which is 0. At pi, it's the x, which is -1. At 3 pi over 2, the x is 0. And then back around to the 2 pi, and my x is 1 again. Obviously, this is the parent function. So as soon as I start to stretch it with my amplitude, obviously those ones become the amplitude, okay? And if I shrink it or stretch it vertically, that's my phase shift. No, sorry, that's my period shift. So I'm actually going to graph this one as a positive 2 first, and then we'll talk about the reflection because I think it's too confusing to start with a negative. So let's start with a positive, like it says 2 cosine 4x, and then we'll talk about what happens if it was negative. So my A is what here, now that I changed it? 2, which means my amplitude is also 2. The B is what? 4. So my period is 2 pi over 4, which is pi over 2. Then I take that, I multiply it. Actually, let me move it over a little bit. Times a fourth, times a half, times 3/4, pi over 8, pi over 4, 3 pi over 8. First one is the 0, last one is the period, which is pi over 2. So this is really tiny. The entire curve is finishing between 0 and 2 pi. So I said it yesterday, but I'm not going to be really picky about how you space it out as long as you're marking your correct key points. If you were to accurately space these out, then my coordinates should all happen before pi over 2, which was our first original mark. Okay, but again, as long as you label the right key points, I'm not going to stress about that too much. So it would be 0. This would be the first one, which is pi over 8. Then pi over 4. Then 3 pi over 8. Then pi over 2. Again, 5 key points. My amplitude is 2. And it's cosine this time. So we start at the amplitude. We come down for the first point in the middle. We go all the way down to the third point. We come back up to the middle. And we go back up to the top. And it's not a V, it has like a curve, okay? So this is smooth and continuous, no sharp edges. So it has a little bit of a curve at the top because those would continue to come down on either side like that if we were to extend our period out. So for right now, we only need the one period, but obviously when we get into, I don't know if you remember, but when you get into the reciprocal functions, secant and cosecant, we have to extend it out. So just keep in mind that at the top, there's a little bit of a curve. Questions so far? So that would be if it was positive. Yep, sorry, go ahead.
On the homework, it asks to find the D of a cosine. What is that?
That's if there's a vertical shift, so we haven't had any of those just yet.
Oh, okay.
Yep. Okay, so now that was if it was like the way that I changed it, right? Now what would happen if this was back to a negative? We talked about it yesterday that a negative on the front of the function does the same thing as every other negative on all of our other graphs, which is what? Flips it upside down. So instead of starting at positive 2, we start at negative 2. We still go to the middle, then we go up to the amplitude, back down to the middle, and back down to the negative amplitude. So if it was a negative 2 cosine 4x, then it would look like that. Same thing for sine. Instead of starting at 0 and then going up, sine would start at 0 and then go down. So just keep that in mind. The negative flips them upside down. Okay, it should look something like this. So your A is 2, which means your amplitude is 2. Your B is 3, so your period is 2 pi over 3. Take that 2 pi over 3, multiply it times a 4 times a half and 3/4. And I got these original points. Pi over 6, pi over 3, pi over 2. Take the 0 at the front and the period at the end, which was 2 pi over 3. There's a phase shift this time, so if I set that parentheses equal to 0 and solve, I get a positive pi over 3. So everything is shifting to the right, pi over 3. 0 plus pi over 3 is pi over 3. Pi over 6 plus pi over 3 is pi over 2. Pi over 3 plus pi over 3 is 2 pi over 3. Pi over 6 plus, no, sorry, pi over 2 plus pi over 3 is 5 pi over 6. And then 2 pi over 3 plus pi over 3 is pi. Those become your 5 key points. So I plotted them on my x-axis, and then the amplitude was 2. I start at positive 2 over the pi over 3, not at 0. And then I come down to the 0, I go down to the negative 2, up to the 0, and then up to positive 2. Questions? So be so careful, because here's what stinks about these kinds of things. People will go through all of those steps and then plot sine. So be really, really careful with your curve. Okay, I don't know if that means as soon as you see the word cosine, draw yourself that little u. Whatever it is, it's going to help you remember to plot the correct curve at the end. All right, now the vertical shift. So this is the D you were asking about, Sai. D is your vertical shift, okay? So if the letters are actually y would equal A sine bx minus c plus d. So those are the letter representations. I don't know why there's such a lag. On what they are. The A is going to go to your absolute value of A is your amplitude. The B determines the period. The C tells you there's a phase shift. And the D tells you there's a vertical shift. It works the same way as every other vertical shift. If we are adding a number, we take everything and shift it up. If we are subtracting a number, it takes everything and shifts it down. So because these initially start as our parent functions, if you think about what sine is, there's 1, 2, 3, 4, 5. There's 5 key points. The amplitude is 1. Normally, this sine curve would look like this. Wait, I plotted too many key points. Okay. Didn't count the 0. There. Would normally look like that, and a shift up literally takes each of those points and shifts it up 2 places. This would go up 1, 2. This would go up 1, 2. This would go up 1, 2, and this would go up 1, 2. And my curve just shifts up. Okay, so again, I would plot the normal curve, and then I would just shift everything up or down at the end. Be careful, because sometimes they put the D at the front, like they say 2 plus cosine x. This is still a vertical shift. If it is separated by a plus or minus, it's still a vertical shift. If it said 2 minus cosine x, still a vertical shift up. Okay, but now the cosine's flipped upside down. So this negative flips it upside down. A positive 2 at the front still shifts it up 2 places. Okay, so just be careful by that kind of stuff. All right, says determine the amplitude and the period of y equals negative cosine 4x plus 1. So we've got a negative on the front. This is going to flip it upside down. The 2 is actually, the negative 2 is your A this time. Your amplitude is still absolute value of that, so the amplitude again is always positive. What is B this time?
4.
Good. So the period is 2 pi over 4, which is pi over 2. And then this plus 1 is going to shift everything up at the end. So that's not a phase shift. That is a vertical shift. Take your pi over 2, multiply it times a 1/4, times a 1/2, times 3/4, and I get pi over 8, pi over 4, 3 pi over 8, 0 at the front, pi over 2 at the end, because that's my period. Plot your key points. 0, pi over 8, pi over 4, 3 pi over 8, pi over 2, amplitude. And the original curve, because it's got a negative, would actually start at -2, go up to 0, up to +2, down to 0, down to -2. And that's what your curve would look like before the vertical shift. But then everything gets shifted up 1 coordinate. So this goes up 1, up 1, up 1, up 1, and up 1. And there's my final answer. So normally, like if you're in class with me, I actually have colored pencils and I say make them different colors, make your colored pencil the final answer so that you know that you've shifted it up. Obviously, if you're at home, you can do the same thing. If you want to highlight your answer, you will be graphing these by hand, which means you won't have a graphing utility for this test. You'll need a scientific calculator, so I'll give you the lockdown one. If you don't have a scientific calculator, you'll have access to that one. Obviously, your handheld scientific is probably easier to work with, so just practice with that one. But you will be graphing these by hand, and then you'll have to submit it like on your work. Like at the end, you'll submit your work, and I'll grade those. Questions? Okay, you do this one, and then we've got one more, and it's a word problem. It's not a graph. One more, and then we're done. All right, A is 2, which is your amplitude. B is 3, period is 2 pi over 3. The negative one means I wrote up 1, but it's shifted down 1. That should be a down 1, okay? Then you do the 2 pi over 3 times the fourth. I get pi over 6 times a half, pi over 3 times 3/4 pi over 2. First one is 0, last one's 2 pi because there's no phase shift. So if there's a line, and there will be, like it'll say phase shift, identify your phase shift, you would just write none for this one. If there was one with a vertical shift, you would write the vertical shift. If it said there was no, if it asked you for vertical shift, you would say there is none. So you would just fill in those blanks. Then you want to apply your key points. No, the first one is that like purple that I kind of dashed. I'd start at 2. I went down to 0, down to -2, back up to 0, and back up to +2. And then I took everything and I shifted it down 1 unit. Questions on that one? Okay, so I just asked a really good question. If the b is a fraction, so like if it said 2 cosine, and this is x over 2 minus 1, something like that. Okay, remember if it's a whole number in, it squishes it, but if it's a whole fraction in, the horizontal one, it actually stretches it out. So that b is a 1/2. So the period becomes 2 pi over 1/2. Keep, change, flip, and I get 4 pi. So that takes your normal horizontal points that are usually done by 2 pi, and it stretches it out to 4 pi. So my 4 pi would be multiplied times a fourth, and I'd get pi, times a half, and I'd get 2 pi, times 3/4, and I'd get 3 pi, and then the ending one would be the period, which is 4 pi. The first one would be 0. That is not very stretched out equally, but you understand what I'm saying. So it actually just takes and widens it. And then that gets you your key points. And then if it was 2 cosine, let's just say this wasn't here, make our lives easier, I would go up to 2, down, down, up, up. And so my graph would be stretched out horizontally. So if the b is a fraction, that's what it does to it. It actually makes it wider on your x-axis. Did that answer your question, Sai?
Yeah,
okay.
I was trying to say the B in class, but I guess I said it wrong.
No, that's right. You're right. I just didn't explain it well, that's all. Okay, so it's just a word problem application, okay? At this point, you're so tired of graphing that you are excited about a word problem, which has never happened in your entire life before. This says you're riding a Ferris wheel, your height h in feet above the ground at any time t in seconds can be modeled by h equals 25 sine pi over 15 t minus 75 plus 30. You'll never have to come up with that function. It's going to give you the function, okay? But this is what happens when you do anything that's cyclic. Anything that happens over and over again can actually be applied to your sine cosine curves. The Ferris wheel turns for 135 seconds before it stops to let the first passenger off. Use a graphing utility to graph the model. So we're actually going to use the graphing utility because you're going to need it for the homework to plug that into the y equals. Let's see, I got to stop and share again. I'm going to do it from the app because otherwise I have to stop and share. So on our graphing utility, we have to group together this. You need to find the sign of all that, which means 2 sets of parentheses. So 25 sine, open parentheses. There's another open parentheses for your fraction, pi divided by 15. Close that one. Open the parentheses again for the x minus 75. Close the parentheses and then close the parentheses after that. Then add your 30. So if you think about this, this is a sine curve, which means it should start at 0. This is obviously not starting at 0. But the plus 30 shifted it up to 30, right? So that's why, let me take a little snapshot of this. That's why it's not starting at 0, okay, like sine does normally. It shifted up 30. Then the amplitude's 25. So then from there it went up to 25, which means that peak should be the 25 plus the 30. So this should be pretty, like, which goes up to that 55. This is like about 55, okay? But that should make sense, hopefully, that you'd have to be able to shift it up and increase the amplitude. Then it says, B says, can I move this now? Probably not. Yeah, there we go. What are the minimum and maximum heights above the ground? So we just said the one. We said if we took our amplitude and added it to our vertical shift, it would be 55. Okay, the minimum height is, look, it doesn't hit 0. So if we go back to our graphing utility, because this is not in degrees, you have to make sure your calculator's in radians. All right, questions for me?
I have a question.
Yeah.
On the homework it says to graph 2 periods. How many
just graph, you can just graph the one and then extend them out in either. So I'm looking for the 5 key points, and then if it asks you to extend it out, you can just try to eyeball it and extend it out. That's what you're going to have to do when we get to the reciprocal functions in the next section anyways.
Okay.
So I'll still look for the same 5 key points, but if I was to graph it, so like if I had 5 key points and it looked like if it looked like that, let's say, then I would just model the same distance either in either direction, that way and this way. You don't have to give me exact points beyond those key points, or I could keep going in one direction, okay? If it was cosine, because we're going to have to do this for the reciprocal functions in the next section, you can even just drop down either side. I don't know why none of that is showing up. Give me like 5 minutes and it will eventually show up psi. Let me try to stop sharing and reshare. Okay, so here was my initial sine curve, and then you can either extend it to the right, or you could send it a little bit to the left, a little bit to the right, it doesn't matter. And then for your cosine curve, which was this one, same thing. I can like drop down the sides to extend it. I can keep going in one direction. I just need the 5 key points, and then beyond that, you're kind of eyeball it, okay?